Experiment 6 is about microwave-assisted aspirin synthesis. Aspirin, or acetyl salicylic acid, considered one of the most widely used medications in the world, is used as an analgesic for minor aches and pains, as antipyretic, and as an anti-inflammatory medication. It is known to inhibit cyclooxygenase, or COX-1, the enzyme responsible for inflammation and pain. The active metabolite of aspirin is salicylic acid, which was first discovered in 1763 from the bark of the willow tree. In this experiment, we are synthesizing aspirin from salicylic acid. The structure is shown here. It has a benzene with an OH, that's a phenolic group, and then a carboxylic acid. It is very acidic because of the OH and the carboxylic acid. Salicylic acid will be reacted with acetic anhydride, then microwaved to produce aspirin. Structure is shown in here. It's still acidic because of the carboxylic acid. However, the phenolic group, or the OH in salicylic acid, is going to be converted into an ester in aspirin, making aspirin less acidic than salicylic acid. This experiment is also an application of green chemistry because there is no solvent. Salicylic acid and acetic anhydride mixed together after microwaving produce the aspirin, no solvent. The ester formed in aspirin is called an acetyl group, thus the name acetyl salicylic acid for aspirin. Preparation of aspirin. We are now making the painkiller aspirin. So I will be weighing 690 milligrams of salicylic acid, and then I'm going to be adding 1.4 ml of acetic anhydride, and then we are going to microwave the mixture. So I already weighed 690 milligrams or 0.690 grams of salicylic acid inside the balance, and this is that sample, salicylic acid lab grade. So again, the weight is 0.690 grams or 690 milligrams. And then I'm going to transfer the sample into the flask, 125 ml e-flask in here. So I will take out the sample that I weighed. And then I'm going to transfer it into the e-flask. Transferred everything. And I always have a support at the bottom just in case I spill it, just like a filter paper. So the other reactant is acetic anhydride, and I'm actually under the hood, and I'm going to be using a straight pipette. So I'm gonna deliver 1.4 ml. So I can go up to 3 and then go down to 4.4. So I need 1.4 ml of the acetic anhydride. So I'm going to be using the bulb, and I withdraw up to 3. So that's 3. And then I will go down to 4.4. Okay? And that is our reaction mixture. So no solvent, is just the reagent, the reactant, acetic anhydride, and then the salicylic acid. And then I'm going to loosely cap it using a glass topper, and then we are ready to microwave. I have the sample now inside the microwave, so I have it covered. And then I'm gonna close the microwave. So this is just an ordinary microwave, household microwave, and I set it on high, and then I'm gonna time it to 3 minutes. So the salicylic acid, after 3 minutes of microwaving, it's actually hot right now. It completely melted. So it's just the acetic anhydride and salicylic acid. So I'm gonna microwave it again for another 5 minutes, but I will do first 3 minutes, and then I let it cool, and then another 2 minutes. So right now it melted. So microwave again. I'll set it to 3 minutes. So I close the microwave, and again set to 3 minutes. After 8 minutes of microwaving, I now took out the sample from the microwave, and I have a little bit of a liquid at the bottom. And I will check for completion of the reaction by using what is called the iron 3 chloride test. So I will compare it with the starting compound, which is the salicylic acid. And I will put a little bit of that sample in one well in the spot plate. So just scoop a little bit. So I'll put it in that well. And then I'm going to dissolve it in a little bit of ethanol later. So I will put a drop of the reaction mixture in one of the wells. I'm going to put it here. So just a drop. I'm going to dissolve both in few drops of ethanol. So like 3 drops. And then I'm gonna put a drop of the iron 3 chloride. So the iron 3 chloride, okay, 10% iron 3 chloride, aqueous. So I'm gonna put 1 drop. So this is slightly yellowish in color because of the iron. So this is our starting compound, okay? And then the reaction mixture, okay? So as you can see, the iron 3 chloride, actually the iron 3 will form a complex which is purple with compounds that contain phenol. So a benzene ring with an OH is a phenol, and then it forms a complex. That's why it's purple. That means that for the salicylic acid, because it still has a phenol, it will turn positive purple color. However, for our reaction mixture, because the OH and salicylic acid reacted, it was converted into another functional group, actually an ester, then it will not turn purple because there's no more free phenol in the reaction mixture. So that means that the salicylic acid was now converted into the aspirin. That's the test for the reaction that it already is completed. We are going to do vacuum filtration later. So again, we have a filter paper inside the balance, and the weight of the filter paper is 0.196 grams. So the next step is to isolate the product aspirin from the reaction mixture after we tested that it's already completed. And then I will now have ice water in here. I'm going to measure about 5 ml of the ice water to precipitate out the aspirin. So I'm going to add it in the reaction mixture. Okay. So you see that it's forming like a blob. At the bottom, it's oily. So to precipitate it out, I can chill it, and also I can scratch the inside for the precipitate to come out. So scratching it facilitates precipitation. If it's not working, I'm gonna chill it here for about 5 minutes. If it doesn't still come out, we will microwave it for another 1 minute. So we let it sit for 5 minutes. So after about almost 10 minutes of scratching and chilling in ice water, the blob is not precipitating out, but there's like a cloudiness at the bottom, as you can see. So it's cloudy. There's an oil at the bottom. That's the product, but it's not coming out of solution. It's not precipitating. It's not precipitating out. So what I'm gonna do is I'm gonna microwave it for another minute, and then I'm going to. So now I'm going to microwave it for another minute, but I'm gonna rinse it a little bit with water. The stirring rod, okay? And then I'm now going to microwave it for another minute. So that's our sample, that's our reaction mixture. So we want it to precipitate and come out of solution. So I'm gonna put it again in the microwave. Just 1 minute. Right? And then just set it to 1 minute. After microwaving it for 1 minute and then chilling it in ice water and then scratching again, it crashed out immediately from the solution. So the aspirin product precipitated out, and you can see the crystals actually at the bottom. So we are now going to do filtration. You see the crystals here. It's white. So some are sticking on the glass. Some are sticking on the stirring rod, so we're going to take that out. But it now came out of solution. So this is now our product. So now we're ready to filter. And then, so again, this setup, filter flask, and then attached to the water aspirator. And then I'm going to moisten that filter paper, the pre-weighed filter paper that we had earlier. So this is now our sample, and then I'm just gonna rinse again with, this is ice cold water in the squirt bottle. So I'm gonna use this spatula to try to clean out the sticky precipitate. So it's wet, it's sticking. So I'm washing it with quite a bit of ice cold water. And now precipitate went through, so you don't see anything in the filter flash of any white precipitation. And then I'm gonna rinse it with a little bit of 70% 1-propanol and water. So just to clean out a little bit, 70% and propanol and 30% water. So about a ml first, and then to rinse out the precipitate, but I will do it here first and see if I can take that out. So that kind of clean out some of the a little bit of the unreacted acidic anhydride. So I'm gonna rinse out. So I'm gonna use a pipette. So what I'm trying to do is I want to clean that precipitate as much as possible. Okay, so now it's a cleanup procedure. Okay, so that's about it, and I think that, okay, so no more water going through in the filtrate and no precipitate that went through, and I'm just gonna turn off the water aspirator, and then we're done with the filtration. So this is now our product. So we're gonna let it dry for a week, and then we will weigh this when it's dry, and then we will do more analysis for this next time. The product aspirin after a week of drying, I'm now going to weigh the filter paper and the crystal. So in the balance I have the weighing both, so it's 0 right now. So I took out the filter paper with the product. Okay, so this is now the weight of the filter paper plus the aspirin product. So it's the crude aspirin. The weight of the filter paper plus aspirin product is 0.915 grams. So inside the balance, the filter paper plus the product. To preserve the integrity of the sample, I will store it in a screw cap vial, and I also label it as aspirin product. And I took out everything from the filter paper and then from the weighing boat. So the product is now stored in a screw cap vial. So for the next step, which we are going to do for analysis, I will store it so I can I don't oxidize it or I don't expose it to oxidation in the air.